Before we sending out the signal, we will use off-key modulation. And the off-key modulation is a form of amplitude shift key modulation. That is represent digital data as the presence or absence of a carrier wave.
Next, we need to work on a bias T. What the bias T will be doing is it will isolate the analog waveform of the USRP output from the DC power supply of the LED. A bias T is a 3-port network used for setting the DC bias point of some electronic components without disturbing other components.
Hello, I'll be working on the transmitter, aka the LED circuit. For the LED driver, we will need to operate the amplifiers as linear devices. We do this in order to keep the amplifier efficiency high, but most importantly we want to reduce the amplitude and phase distortions, which will cause interference and power losses. A high drive level leads to more distortions, so in order to fix this problem, we will keep the system within a voltage range to keep the operation in a linear fashion and within a current limit.
We will be using a Hamamatsu S10784 photodiode to receive the signal. It has a response of 300 MHz at 650 nanometers, which is more than adequate to achieve our desired data rate of 100 megabits per second. A transimpedance amplifier will convert the current output to a voltage that will be amplified and fed into the input of the SDR.